Okay, so welcome back. We are at lecture 15 after a week off, I suppose, right? So hopefully everybody had a good week off. Hopefully it was very productive. Hopefully people maybe used that time to work on their projects. Maybe, maybe not. I worked on my project a little bit in the Beijing airport on the way back here from the States, although it was weirdly cold there. Like apparently they don't heat the Beijing airport and it was snowing. So I had to work on it for a few minutes and then I gave up and I had to walk around so I didn't freeze to death. But I've been working on my project. Hope you've been working on yours. Mine is not for credit, but I'm still going to try to do my best along with you guys. Okay, so let's talk about a few things like what we're going to do today and then just jump right into it because I'm sure you guys are eager to get to the Matlab stuff. By the way, I apologize for my voice. As you can tell, I've got a little sinus thing. Not too contagious or anything, but I'm a little bit raspy, so hopefully you can hear me. If not, just tell me to speak up, please. So today we're going to finish up what we started last time, hopefully, which is to talk more about Psychtoolbox, talk about sound, keyboard, and timing. We had just started on showing you how to play sounds last time, so we'll do more of that today with this McGurk demo. And then, to some extent, we'll get into the next topic, which is dynamic stimuli, by which I mean, well, we'll talk about what I mean by that, but basically I mean creating stimuli or modifying stimuli as you go, which is something you can't do with a piece of software like ePrime. You can't change an image file that you're going to show in ePrime, but you can do that with Matlab. And you can do it with PsychoPy too, but it's a little bit easier, I think, to do it with Matlab. So that's why we're talking about that. So we've got some kind of cool things lined up to show you with how you can change your stimuli on the fly as your task is going. So I think that'll be a cool demo to show you guys really how powerful programming with Matlab and Psychtoolbox can be. And we've got a few more weeks to go. We'll see how much of this other stuff we get through. If we don't get through a ton of data analysis, I think that's okay. Because I really want you guys to at least understand PsychoPy and Psychtoolbox. Okay, so you're all aware that problem set 8 is out. I haven't yet had a chance to really look at problem set 7 too much, but I will get to that soon. Problem set 8 is due Monday. I will release problem set 9 the same day. Hopefully you guys are not finding these too bad. I'm trying to keep them a little bit less hardcore than some of the ones from first semester. If you are having problems, let me know. But I'm trying to keep them pretty simple. But problem set 9 will probably focus, depending on how you do on problem set 7 and how it sounds like you're doing on problem set 8, problem set 9 will probably focus a bit more on doing your own Psychtoolbox stuff. I just talked to everyone about project due dates. We talked a little bit about this before, and I was actually misinformed or wrong that I thought we could only have things due on the actual weeks of class, but it turns out we can have things due the study week. So, to give you guys a few more days, I decided that let's make the projects due the Thursday of the study week, which is the 2nd of May, I believe. I was going to make it the Wednesday, but that's a holiday, so you can have the Wednesday to finish things up, and then it's due Thursday, 1 minute before midnight. We'll talk about submission method closer to the time, but it'll be electronic, similar to the way you've submitted the other stuff. So it'll be due right before midnight. And basically, I could have made it due a little bit later, but I don't want to, I want to leave you guys a few days that you have to study for your exams and stuff. So let's make it due partway through the study week. So you have a few days of the study week to finish up the project, but a few days to study or work on your other classes and stuff. So hopefully that's a good compromise. We'll see how that goes. And again, we'll sort of see in the last few weeks of this class how much time in class we might want to devote to project workshopping. But hopefully we'll have at least one other project workshop day. Okay, any other questions or administrative issues, other issues? Everybody good? Okay, so today's going to be pretty demo heavy because I want you guys to get to play around with Psychtoolbox a fair bit. So if you remember last time, we had talked about the McGurk effect. We talked about, just a little idea I had mainly to demonstrate these ideas of, audio and dynamic stimuli and so forth. and a task that uses both sound and text. But the idea was, let's see if we can determine whether text can influence your perception of phonemes or sounds of people speaking, right? The same way that videos of people actually, like people's mouth movements, can influence your perception of phonemes. So let's continue with that demo if we can. So we'll go ahead and start up. Everybody start up your Matlabs. This will be a good one, I think. I go back and forth as to whether I think it's better for you guys to just watch or kind of type the code in along with me. But I think this is a good one to type the code in along with me if you haven't been already. Because I think this will be a fun one to kind of stop and, explain along the way what's going on. So I think I put all the code up last week, the Lecture 14 code, online. So if you need to go to the class folder on Google Drive, you should be able to do that. What I'm gonna do is a little, don't do this. This is Mac magic. I'm gonna make a copy of Lecture 14 code called Lecture 15 code. Ooh, there we go. And I'm going to edit code in here so that we have a pristine copy of the code as it stood last week. And I'm going to go ahead and, if you recall, we had these 3 sound files, ba, ga, and da, and just a code file called McGurk demo. So if you can remember all the way back to last week, we didn't get too far. We got so far as explaining how you can use this wave read function. Let's see, where is it there? That's built into Matlab to read in a sound file, specifically a Windows wave format sound file. We read in the sound data. We talked about how Psychtoolbox uses something called Psychport Audio to play sounds, and we went ahead and made a little for loop for a number of trials that right now is just 10 trials. And for right now, all this does is select a random syllable, fill up this Psychport Audio object, with sound information and play it, right? So all we get now is 10 random syllables of sound. If you want to remind yourself of what this does, I'll play it. So if you're listening on the podcast, be ready for loud sound to come now. So here's what we got so far.
Ga, ba, ga, da, ba, da, ga, ga.
Okay, pretty exciting stuff, right? But we haven't done the text part of things, right? So we know how to play a sound, but we don't know how to do the full task. So let's look at building that task now, and we'll sort of explain some other Psychtoolbox stuff as we go. So let's see what we have to do. So now let's build in a little bit of a task element to this, because all we have done is sound so far. We haven't displayed any stuff on screen. So I guess one thing we'll have to have is we'll have to have instructions, right? Like we did for PsychoPy last semester. So I'm going to make a new variable called instructions text at the top of the script, and I'm going to make this a cell matrix. And if you remember, we introduced cell matrices last time. Remember, a cell matrix is a way of collecting any old type of data together, right? So it's a good way to store like 3 or 4 strings of information. So in this case, I'm going to have I think 3 strings for 3 pages of instructions text. So our instructions might be something like, please place the index, middle, and ring fingers of your right hand. And if you remember Python, if we wanted to insert a new line or a return character, we used \n. Same thing in MATLAB, \n of your right hand on the 1, 2, and 3 keys, \n for a couple new lines. And let's say press any key to continue on the first screen of instructions. And I'm ending that with a semicolon so that I can put the next string on the next line. Basically, this is going to be a 3. So cell matrices, in case we didn't talk about this last time, just like any other type of matrix in MATLAB, can be 1-dimensional, they can be 2-dimensional, If they're one-dimensional, they can be either a row or a column. So we're going to make a column cell matrix with 3 strings, like one above the other. So remember, we do that. We separate different rows with a semicolon, right? So if I want to put something on the next row of the cell matrix, I can do that here. On each trial, read the word and listen to the sound. A couple new lines. Then select the choice that best matches what you heard, and press any key to continue. This was obviously not the most exciting part of this, but have to do it. All right, so there's that, and the last page of instructions will just say press any key to begin task. Okay, so that's pretty easy. And remember, we have to end the cell matrix with another squiggly curly bracket. And if we don't want this whole thing to print out when this line of code runs, remember we end the whole thing with a semicolon to prevent that the output of that line from printing to the Matlab command window. Okay, so we'll do that. And so let's just get the instructions text up on screen, and then we'll sort of build up the task from there. Okay, so what I like to do in Psychtoolbox, we talked a little bit in the problem set especially, and beforehand, once you put up that window on the screen, life gets complicated, right? Because if it crashes, it's a little hard to debug. Although, I learned a trick just this week from a friend of mine that is going to make your lives a lot easier, actually, when you're working with Psychtoolbox code. So, good news for you is all that stuff in the problem set about how you have to hit Control-C over and over again and type SCA to clear the window. We actually should be able to get around that now. So, that's a piece of good news, actually. So, but even so, one thing I like to do is I like to do as much as possible before I create the Psychtoolbox window, because then if there is a crash or something like that, we don't have to worry about clearing all that stuff out. So let's create our window right after we load in all of our sound data. So let's do this. Well, we can do it anywhere in here. So load in the sound data. So let's put it right here after we create the psychport audio. Let's maybe delete that line so all of our sound stuff is together. So remember, we have this oops, I didn't copy it in there actually. So let's copy it in there. Let's list. Okay, so I have this PFP PTB init. I'm just going to put a copy of that in Lecture 15 code so that we can access that. Again, if you guys are keeping all of your code in the same folder, you don't have to do that because you should already have a copy of PFP PTB init. But we're going to be needing that to initialize. To initialize Psychtoolbox. So I'm going to put a copy of that in Lecture 15 code. Oops. Oh. I'm dumb. Lecture 13. Okay, another little piece of Matlab, or not Matlab, Mac command line magic, and let's do PFP PTB cleanup also. Put that in there. Okay. Okay, so now we've got our initializing and cleanup functions here, so we can call PFP PTB init, and remember that if we want to create a window, we have to save it in variables called myWindow, and we probably also want to save the rectangle that describes the boundaries of the window. Right, and again, remember this PFP PTB init, that's not a Psychtoolbox function per se, that's a function I wrote for you guys' convenience that does a lot of things that you don't need to understand just now. It's all the smaller code for creating a window, popping up that message that says, here's what your current resolution is, and so forth. But basically what it does, is it starts up Psychtoolbox and gives you back a variable that represents your window and a variable that tells you the size of it, basically. Okay, so we've created the window. Let's see what we'll want to do. So just to draw the instructions text, before we do any trials, let's have a little for loop to do the instructions text. And again, this is just like what we did in PsychoPy before. So you might have noticed I like to call my counter variable in for loops I. That's sort of a MATLAB convention, but you can call it whatever you want to. So I'm going to go from 1 to the length of the instructions text. And I think we saw this length function before, right? So maybe not. Did we do this length function before? Have we used this? We've used size before.
It's in Rick's code.
Did we do it before? Oh, that's right. I think we talked about it last time. Right. So remember, length just tells us like if we've got a like a cell matrix or any kind of matrix really that's a row or a column matrix. It just tells us the length of it, right? The longest dimension. So for example, here we've got 3 items in the instructions text, so the length of instructions text should be 3. Okay, so we're going to do something 3 times. So what we're probably going to want to do is first just flip the window, and that's just to kind of clear out, clear out what's in it. So flip my window, and then maybe we'll wait a short amount of time before we pop up the next screen of instructions, like 1/2 second. And then, let's see, have we used draw formatted text before? I'm trying to remember. Okay, so here's a new function for you for drawing text. It's called draw formatted text. Let's look it up on the, well, assuming our Psychtoolbox help is working. Okay, so if you look up Psychtoolbox wiki, draw formatted text, you'll see some of the things that you can do with it. Of course, it's going to be slow. Well, I'll go ahead and tell you. The first thing you give it is your window, right, which we've called my window. The second thing you need to give it is the text you're going to draw. So I'm going to give it instructions text. And I'm not going to just give it instructions text, because instructions text is a cell matrix with 3 strings inside of it, right? So I'm going to just give it one of those 3, and it's going to be whichever, like if I represents which time through the for loop we are, it's going to be the ith, one, first, second, or third item in the instructions text. So like, let's say instructions text, curly bracket, I. Remember that gives us, just like if we have a list in Python, just like other matrices we've seen in Matlab, this gives us item number I of the instructions text. The only difference is because it's a cell matrix, we use these curly brackets, right, instead of parentheses or square brackets. Okay, so here's the help for draw formatted text. Again, you see there's lots of optional things. Remember in Psychtoolbox's documentation, these little brackets around the variables means that they're optional. That's just sort of Psychtoolbox's notation on the website. So you have to give it a window, you have to give it a t-string, which is the text string, right? Draws a string of text called t-string into the Psychtoolbox window that it calls win. Then you can add some other things. So if you leave out SX, the text starts at Exposition 0. Otherwise, it starts at the specified position SX. If SX equals center, then each line of text is horizontally centered. SY is the Y position. Same thing. If it's center, then you center it. Otherwise, you can draw it a specific pixel. And then you can specify the color. You can specify line wrap, things like that. So a lot of the same things you can specify with Psychtoolbox. Okay, so for now, let's just give it the window, what the text is. We'll tell it to center it in both X and Y, because otherwise it's going to appear at the top left of the window, which is not what we want, which is different behavior than PsychoPy. PsychoPy by default centers text. Psychtoolbox by default puts it at the upper left, and we want to center it. And we could give it a color. If we do want to give it a color, I'm going to define a variable called text color. And I'm going to spell it the American way because it's spelled the American way in Psychtoolbox, so just to keep things unconfusing. And the color I'm going to call it is 255, 255, 255. In MATLAB, usually this is a red, green, blue color code basically, where it's 3 values that can range from 0 to 255. This is generally how colors are represented. So 255, 255, 255 is maximum red, maximum green, maximum blue color values. Anybody know what that color is going to be then? What is it? I hear, it's going to be white, okay? So if we want white text, that's the red, green, and blue pixels turned on all the way, which is white. So we've defined a variable called text color up here, so now I'm going to give draw formatted text that text color variable. And that'll tell it to draw our text in white. But remember, of course, when you say to draw something, it doesn't actually draw it to the screen directly, right? It draws it to that invisible, window that we haven't yet flipped around yet to show to the real screen. So of course, after you draw it, you have to call another flip of the window. And then the last thing we're going to have to do is wait for a key press to go on, okay? So the function for doing that in Psychtoolbox is called kbwait. Let's see if we can, yep. So you can look up the documentation for that here. There are various things you can give it. So you can give it a device number. If you've got multiple keyboards, that's sometimes useful. Usually not particularly useful because you've usually only got one keyboard. What is for what? For what is... For what? I forget what for what is, but it's useful. Okay. So you can wait for releasing of keys if you set for what to 1. If you want to wait for a single keystroke, set the for what value to 2. That's probably actually what we want. So this is actually going to be how we call kbwait. And you see that kbwait can return up to 3 return values. Right now, we don't really care what the key is that people actually press, right? But it could return when the key is pressed, what the key code is, so what key is pressed, and something called delta sex, which is, I think, how long it's been since the last time a key is pressed, or something like that. You see that even I have to, I never use the delta sex parameter, so even I have to, oh, it doesn't even tell us. Somewhere in the documentation it will tell you. Anyway, it's not that important. I never use it. But anyway, so what we're going to want to do is use kbwait, right? So if we want to wait for a keyboard, if we just want to wait for any key press, you can just say kbwait, empty brackets, comma 2, which means any device, because we don't specify a device number, we just give it an empty matrix. So that means any keyboard you've got attached is fine. And then what we're waiting for is a single key press, okay? Now, in theory, this code should work. We should get instructions and then a bunch of ba, ga, and da. Obviously, the full task is not ready to go yet, but we're getting there. So again, watch out on the podcast for loud noises. Okay. Okay.
Ba, ga, ga, da, ga, ba, da, ga, ga, ga.
Oh, I forgot to do something very important here. Anybody have any idea what I did? The task is over. My script is actually over. But what I forgot to do was call my PFP PTB cleanup at the end to clear off my screen. So I was a bad boy. So if you don't, that's one weird thing about Psychtoolbox, right? Is if you don't clean it up at the end of the script, it just leaves the screen up forever. So make sure PFP PTB cleanup at the end, and you're good to go. Now let's just run that again. Make sure that's right. Again, if you're listening to the podcast, watch out for loud noises. It looks like our instructions are working.
Ba, ga, 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 da, da, ba.
Okay, great. So cleans it up. Now I did promise you a magical method for handling bugs and things if you do get stuck on that screen. Now that's not, well, that actually will work even if I forget the PFP PTB cleanup line, if I remember to put in this magical line. So let's say I had an error somewhere in my script. So let's say after the instructions happened, I had some bug in my script. And actually, you can cause errors yourself. I mean, well, you can cause errors unintentionally all the time, right? But if you want to intentionally cause an error to happen in your code, you can actually use the MATLAB function error. Like, here is an error. So like sometimes if you want to crash your own code, for example, like if you write a function and the function determines that the person hasn't used it correctly, and you want to give an error saying like someone used this function wrong, you can actually send an error message yourself and cause the code to stop running. So just as an example, here's how it'll be right now if an error happens in this code. So instructions, 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 and then I don't know if you heard the little Mac error boop, but it caused an error, right? And as we have it now, like I said, you have to do this thing where you have to hit Control-C, type SCA, and then run your PFP PTB cleanup. So that's a little annoying. I showed you how to do that in the problem set. Hopefully you guys have been okay with it. But if you want some magic special sauce to deal with that, you can thank my friend Matt Krause for this. We trade MATLAB code all the time because that's what we do. And this is, again, just going to the lesson that like none of us knows all this, like all of this stuff. We're all learning all the time. Because I had never heard of doing this before. You can include a line of code like this. And I don't even want you to think about what it actually does. But if you include this exact line of code, it should work to automatically call, basically what this line of code does. So I would put this line of code in somewhere near the top of your script before you do anything but maybe define your variables, like define your global variables for your task. What this line of code essentially does is say, well, what it really is doing is it's creating an object in MATLAB, and we said that MATLAB does have support for objects, but we don't really use them very much. At least we don't. Not the same way we do in Python, but what this basically does is create an object that calls PFP PTB cleanup to kind of clear away the Psychtoolbox whenever the script finishes. So that includes whether you have an error or whether it finishes normally. So in theory now, when we have this error, if I call McGurk demo again, instructions, instructions, instructions. Okay, so you see, here is an error, but it automatically cleans up for me. So if you include this magic line, and of course, if you've got your PFP PTB cleanup function here in the folder where your script is, because it has to be able to find it to call it, you actually don't have to worry about that Control-C, SCA, all that business to clear away the MATLAB or the Psychtoolbox window. And if we take out this line at the end that cleans up the code, or cleans up the screen rather, again, let's take out the error as well, right? Because there really shouldn't be an error in the middle. If we run that, again, watch out on the podcast for loud noises coming in. Okay, here we go.
Ga, ba, 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 ga, ga, ba, ga, ba.
Okay, see, now the cleanup is done automatically for us, even though we don't have a cleanup line at the end of the code anymore. What this basically does, you see it's called on cleanup. Basically what that means is when this script finishes or when this function finishes, call this PFP PTB cleanup. So essentially it's saying whether you have an error or whether you end the function normally, call this before it totally ends, okay? So the short story is, even if you don't totally understand what this line does, if you stick this line in all of your Psychtoolbox code before you create the Psychtoolbox window, you should have to not worry about ever getting stuck with a Psychtoolbox window on your screen which is pretty good news. So thanks, Kraus, if you're listening. We have used your tip. Okay, so any questions so far? Is people's code working? Anybody need to take a break and debug? Or are people like just totally not following along at all? Anybody raise hands if anybody need a break yet? All right, I'm going to take that to mean that we want to keep going because everyone's super excited about seeing how this task goes. Okay, so we've got our instructions. You guys see how draw formatted text works. You see how you can wait for a key press. So really, it's not going to be too hard to extend this task to now do what else we have to do, which is to present some text on screen to see if that influences our perception of the syllables, and then ask someone for a response, right? So let's go ahead and do that. So what we probably want to do is, again, just to make things easy, I guess what we'll say is in the design of this experiment, we will randomly select a syllable to play, and we'll randomly select a bit of text to display with it. And then, we can analyze the behavior and see if, whether the text matches the syllable, whether that influences your judgment of the sound, whether it makes you worse at it or just makes you slower or whatever, right? So remember last time we used this randi function to select a random number between 1 and 3, right? Because the number of syllables we set up here was 3. So let's also not just select a random sound number, but let's select a random number for the text of the syllable. So let's call this text num or something like that. And that'll be another random number between 1 and n syllables. So of course that means those random numbers are selected independently. So they might both be the same random number. They might both be 1, or maybe one is 1 and the other is 2. They might match or they might not. All right, so we'll do that. So let's then select the text to be displayed. So we can call it something like this text. And that's going to basically be, we have a list of syllables defined already, right? So it's just going to be syllables, curly bracket, text num, right? Because it's just going to be syllable number 1, syllable number 2, or syllable number 3. So this text is now a string that either has ba, da, or ga in it. So then we're going to have to do some stuff that, now we've filled our, we'll fill our audio buffer with sound. But before we actually start the sound playing, we'll probably want to put the text up on the screen, right? So let's do, remember the first time we go through this loop, we've still got the instructions up on the screen. So the first thing we'll probably want to do is flip the screen. And because we haven't drawn anything into the screen, right? Like we had the instructions text drawn, and we flipped to show the instructions text, but then we haven't drawn anything else yet. So when we flip this time, that's basically just clearing the screen, right? So we flip to clear the screen. Let's wait about 1 second just to have some blank space in between trials. Then we'll use one of these draw formatted text. And so this time we're going to want to draw. So again, see Matlab, I think your version will do this as well, right? We'll give you a little guide as to what the, sort of like Python does, give you a little guide as to what the possible parameters are, right? Just to help you remember. So the first thing is going to be the window, which is my window, not my widow, my window. The next thing is the text string. So the text we're going to want to draw is this text, which is the text of one of those syllables. And for now, we're probably going to want this to be centered as well. So X is going to be center, Y is going to be center, again, spelled the American way, USA, USA. And we'll draw that in the text color, also spelled the American way. So we've drawn the text to the, the buffer or the invisible off-screen window. But of course, then we're going to want to flip it. So it's visible, right? Okay, and that's probably good, actually. So let's see what this does now if we just run this. And watch out for loud noises on the podcast. So what this should do is display now the text of syllables randomly that may or may match with the sound that's played.
Da, ga, ba, da, ga, ba, da, ba, ga, da.
Okay. Well, I can already tell you from this experiment, the text is not going to influence you very much as to what the judgment is of the syllable, right? It's still pretty obvious what the syllable is. But that's okay. We can change that later to make it a little harder. But the basic experiment works, right? One little thing I'm going to do is, that's a little slow, so I'm going to turn the that weight sex down from 1 to 1.5, which will speed it up a little bit. So just do that again. Okay.
Ga, da, ga, da, ba, ga, 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 ba, da.
This kind of drives you insane after a while, I know. Okay. But it does work, right? So it displays a random syllable, plays a random syllable audio, which is exactly what we want. But we need to now ask the person to like make a judgment, right, as to what the syllable is, because that's the question in the experiment is, you know, we want to measure accuracy and response time. So what we're going to have to do is, after the sound starts playing, we're going to wait half a second, like we just did there, and then we're going to want to put up a screen that asks the person to make a response, right? Now to do this, let's make a few more variables for what people are going to, like to tell people what to say. So I'm going to make another little variable here called response key labels, which is basically going to be like telling you to press 1, 2, or 3, whether you think it was ba, ga, or ba, da, or ga. So the first one, and I'm going to use a cell matrix again for this, is going to be the string ba, then a new line, and then just the number 1 in parentheses. So what that should display is ba, and then a line, and then 1 under it in parentheses. And then the same thing with da, new line, 2, and then ga, new line, 3. Close the cell matrix. Remember that semicolon? Okay, so now what we can do is we can, well, we can draw that text on the screen. What we're probably going to want to do, so what I want to do is like draw those labels at like here, here, and here to sort of tell people what to press, right? So one thing I might need to do is some calculations as to what those coordinates actually are. So back up here, I'm actually going to do this right when I make my window. I'm going to get I need to get a measurement for like what the center of the screen is so I can like move things a certain number of pixels left or right of the center of the screen, or up and down, right? So if I want to get the center of the screen in X, that'll just be, remember that we have this window rect, which tells us the left, top, right, and bottom borders of the window in pixels. So if I want to get the center of the screen in X, that's just the left and the right coordinates averaged. So that's going to be window rect 1 plus window rect 3, and all of that divided by 2. Okay, because remember, a rectangle is a list of 4 numbers, or technically a matrix or a vector of 4 numbers where they go left, top, right, bottom, right? So it's, or correct, question mark. So in other words, window rect 1 and window plus window rect 3 is the left coordinate, the left edge of the screen coordinate, plus the right edge of the screen coordinate divided by 2, which averages them, right? And then to get the y center, we do the same thing with the top and the bottom coordinates. So we average the top of the screen coordinate and do it that way. Now, practically speaking, what window rect probably is, because we have a 1024 by 768 window in this case that I'm projecting. What that window rect probably is going to be is 0, 0, 1024, 768, because that's usually how it gives you. So I could just really divide the right and the bottom by 2, but who knows? They may change their coordinate system sometime. I think if you have 2 windows, like if you have 2 monitors and you don't set it to mirror, I think these coordinates can get kind of funky. So it's a good idea to just average the left and the right coordinates and the top and the bottom coordinates and not assume that any of them are going to be 0. So now we've got a measure of the center of the screen in X and the center of the screen in Y in pixels. So now what we can do is we can, well, I could just use a raw number, but I'll give it a label just to be nice. So I'll call this something like response key label spacing. This is just how far apart they're going to be. Let's say it's 200 pixels. And I'll just remind myself it'll be in pixels. So I'll place them 200 pixels apart. And now what that'll let me do is calculate an initial text X position. And I'll set that equal to the X center of the screen minus the response key label spacing. So basically what that'll do is like say, all right, we're going to start off drawing text, 200 pixels left of the center, right? Because remember, negative is towards the left of the screen. And we'll start off the text Y position at Y center. And if I want to maybe I'll move it a little down. I think that looks nice. So let's put it 100 pixels down. Remember that plus is either to the right or down, minus is to the left or up. So this will put it 100 pixels below center. Okay, so then all we have to do is we'll have to have a little for loop. If I've already used I for a for loop, I can't use it again, right? Because we're in the loop that uses I, so I'm going to have to use a different counter name. So let's call it J equals 1 to 3. Then I'm going to want to draw these 3 text things. So draw formatted text. My window. The text string is now going to be one of the response key labels, right? So response key labels, curly bracket J, right? Because that says J is going to go from 1 to 3. The first time through, we're going to draw the first response key label, the second time the second response key label, the third time the third one. And then now we don't just want to center the text, right? We want to put it where we've calculated. So the X location will be the variable we call text X position. The Y location will be the one we call text Y position. And the text color we can just keep as text color. And then all we have to do is and then we want to move the text X position for the next piece of text, right? Because we don't want to draw them all on top of each other. So let's say text X position equals text X position plus response key label spacing, right? Because we want them 200 pixels apart. We'll just add that many pixels. So that'll draw the 3 response key labels on the screen. Then we can flip the window to show those. That should be the same as before. And then what we have to do is wait for a key press, right? Now we could do this a couple different ways. We could just wait for any old key press and hope for the best. But I think that's probably not what we want to do. So like up here, we're just waiting, we're just using KB wait to wait for any old key press, right? But down here, remember like when we did this in PsychoPy, often we used a while loop, right? Because we said like while they haven't pressed a good key, because we only really want to stop, waiting for a response when they press 1, 2, or 3. So we might want to use a while loop here also and wait for them to press 1, 2, or 3 and just keep checking until they did. So what I'm going to do is create a Boolean variable called good key pressed and set that equal to false. Remember lowercase f because it's MATLAB, not Python. Then have a while loop that says while not good key pressed. Have we used this little not symbol before in MATLAB? I think we have, right? So remember the little tilde? Yeah, that's right, because we had a debate over whether it was tilde or the circa key or whatever. So that means not, remember. So while that is not true, that we've pressed a good key, to keep things simple, we'll still use KB wait. We could use another function called KB check that checks the keyboard to see if any keys are down, but KB wait should be fine to use here. So we're going to call KB wait, but this time, unlike up here we didn't really care what they pressed or when they pressed it, right? But here we're going to want to actually use those outputs of KB wait. So if you remember, KB wait can give us the time the key was pressed, the codes of the keys that were pressed, and it can also give us this delta sex thing, which I said I don't remember what it is and we don't care about it. So we're going to want to get the key time, which I'll call key time, which is when the key was pressed, and the key code, and that's going to be equal to KB wait. And we can again give it empty brackets and 2, meaning that we want to wait for a single key press from any device, no particular device. No particular device, and this code 2 just means, remember it says we want basically a key press downward, not a key press upward, or a release of a key, basically. Okay, now how do we know what key is pressed? So maybe it's time for a little demo to see how KB wait works. So let's actually go back to the MATLAB command line. We can actually, if you ever need to test out KB wait, you can do it right here on the command line. So if I want to say key sex, key code, I should technically put a comma, although it'll work either way. I could do this on the command line. All right, so we get this crazy, I hit the K key there. We get this crazy output there because so key sex gives me a time, which is, who knows what this time code actually represents. It's some measure of seconds, several thousand seconds. So I think it's actually, what key sex actually is the timer represents the number of seconds since the computer was turned on. But of course it doesn't matter, right, because it's all relative. So it's whatever time the Psychtoolbox internal timer says it is. And then it gives us this matrix of key codes, which is basically, you see it's 256 items long, meaning that's all the keys that are on your keyboard and then some. And basically it gives you a 0 if a key was not pressed and a 1 if it is pressed, right? So if we look, there we've got a single 1, and that should be the only thing that's a 1, right? Because I only pressed 1 key. So if you want to know what the key was that I pressed, there's another Psychtoolbox function called KB name, and you can just give it the key code, and it'll tell you I pressed the K key, which is helpful. So I'm going to do the same thing again with the semicolon. And I'm going to press the 1 key. So you see it typed a 1 there because I pressed the 1 key. And if I want to see what that calls it, now that's a little interesting. It calls it 1 exclamation point. If I press the 2 key, it tells me that's called 2 @. And if I do it again, it tells me 3 is named 3 sharp sign or octothorpe, right? So that's a weird little thing of Psychtoolbox. So you actually have, well, I don't on this laptop, but you guys have a 1, 2, 3 key on your number pad and a 1, 2, 3 key above the keyboard. Psychtoolbox actually distinguishes between the set of number keys above the keyboard and the ones on the number pad, right? So you actually want to call these keys by the appropriate names if you want people to press the ones above the keypad versus the one, or sorry, above the keyboard versus the ones on the keypad. And you'll see like there are other, like if I want to see what the name of the spacebar is, for example, press the spacebar and get the KB name of that. So it's called space, right? So if I wanted to wait until someone pressed the spacebar, I could look for a key whose key code is space, or key name is space. If I wanted to wait for someone to press shift, it's called, well, I pressed the right one, apparently that's called right shift. If I wanted to wait till somebody pressed escape, I could see, oh, okay, it's called escape in all capitals for some reason. Okay, so that's just to tell you that's a quick little way that you can learn the keyboard, or the key names of all the keys on your keyboard, right? That Psychtoolbox refers to them by. Okay, so what this is basically going to want to tell us is we're going to want to define what keys we think are the good keys to press. So if I want them to press either the 1, 2, or 3 keys, and actually because I'm doing this on a laptop, I want them to press the ones above the keyboard because I don't have a keypad. So let's call this like response keys. And I'll use another cell matrix. You guys see that cell matrices are coming in handy here. So I think the good keys are the 1 exclamation point key, the 2 @ key, and the 3 sharp sign key. Of course, we could have told people to press, you know, the V, B, or N keys, you know, kind of in the center. Could have told them to press the T, Y, or U keys. You know, you can pick whatever keys you want. But for now, let's use 1, 2, and 3, because that illustrates the point well. So we've got these 3 response keys we want to wait for. And back here, what we basically have to do then is we're going to wait for a key press, and that'll give us a key code. And remember that key code represents, it's a list of 256 logical values or Boolean values, right, as to whether each key on your keyboard is pressed or not. So what we want to really do is first convert key code into the name of the key code. I'm going to just still use the variable name key code. So basically this is going to turn key code from a list of numbers to a string. That's just to avoid creating too many variables. Now, here's a little trick. Remember, you could press more than one key at once, and I've had some weird, obscure bugs occur in my code where I didn't anticipate that someone might press 2 keys at once. So for example, let's see if I can do this. If I mash like 4 keys at once, and I try to get the KB name of that key code. Oh, that's interesting. Oh, you know why? Forgot we did this. It's actually going to make life easier. Okay, so that should be working. If I take this out, actually, let's see if we can get this working. Oh, shoot. Oh, there's all kinds of things with KB wait. Let's try this. All right, so one thing I was going to tell you, we probably don't have to do, actually. All right, so there you see that what I got was 2 keys at once. But actually, I forgot that so basically, when we don't specify that 2 at the end of KB wait, that 2 basically says I want to wait for exactly 1 key press. So if you do that, it tells you, whoops. Oh, wait a minute. That's weird. I wasn't doing that before. Okay, I guess I just wasn't pressing them simultaneously well enough before. Okay, so actually this is what we get, right? So if I press more than 1 key at once, all right, I totally lied to you earlier. You can still get multiple keys at once if you're good enough at pressing 2 at a time. All right, anyway, I can't do it again now, apparently. Okay, anyway, all this is to say, you just want to be careful because you can't always assume that people are going to press only 1 key. I found that every once in a while, somebody will actually accidentally press 2 keys at once, and if you you can accidentally crash your code if you treat the output or the key code as being a single thing when it's actually two things, right? Because if I want to test, for example, if I want to test, let's see, my key equals KB name key code. All right, so my key is K. So if I want to see if my key is equal to K, whoops, my underscore key is equal to K, that's all right, but let's see if I can get this, let's see if I can do this with multiple keys now. Whoops. Oh, that's an interesting one. Okay, so now I've managed to press two keys at once, right? So if I do now, if I want to test to see, so if I say my key equals the KB name of that key code, that's okay. That tells me my key is equal to D and S. And what kind of data is my key now? Before it was just a single character string, right? But now it's actually, if you look up here, it's a cell matrix. It's a 1x2 cell matrix, like the kinds we've been creating in our code with two items in it, right? So what this means is if I then say my key, if I want to test and see if my key is equal to, say, K, I get an error because you can't compare a cell matrix with two things in it to a single string, right, or a single character in a string. So that's maybe a long explanation for the basic point here is that, remember in Python, every time we checked for a key pressed down, we just wanted to take the first key press just in case people picked multiple items or pressed multiple keys. We're going to want to do the same thing in Matlab or Psychtoolbox. Just in case people press multiple keys, we only really want to check, well, you know, ideally they don't press multiple keys at all, but if they do, we want to only check like the first one just to make sure. Or don't check it at all if they press multiple keys. So what we'll do in this code is just not count it if they press multiple keys. Okay, that's just to keep your script from crashing because, as I can tell you, I've had scripts where, like, I had a task that was working perfectly well, and we were doing EEG and eye tracking and all kinds of complicated stuff, except once every, like, 10 subjects, it would just randomly crash for no good reason. And we finally figured out it was when people accidentally mashed two keys at once. And we weren't testing for that scenario. Okay. So there's a very easy way to test this. And basically what MATLAB can do sometimes is if you ask it, it can tell you what kind of variable something is. Okay? So basically one way of testing whether somebody pressed two keys or not, right? Because if they pressed one key, like your key code is just going to be a single string or a single character, you know, like this, right? Where it's just the letter K. But if they press two keys, it's going to be a cell matrix with the two key names inside of it. So one thing you can do is you can use a function called isCell, and that will tell you whether or not the thing that you give it is a cell matrix or not. So if I get another key press, just K again, and get the KB name of that, see that's just K. If I set my key equal to that, and then I test to see if my key is a cell. Now it's not, right? Because it's just a string. It's just a character. You see that my key is just K, right? So what we can do is we can test to see if, if key code is a cell. Basically, that means they pressed more than one key at once. Actually, so what we probably want to do is only do the check if it's not a cell. So basically what this means is if it's not a cell, we'll check and see if the one key that they pressed is one of the good ones. And to do that, what we're probably going to want to do is to go do a for loop again. So for j equals 1 to length of our response keys. So basically what we're going to want to do is check all of our response keys and see if the key that was pressed is any of those. And the way we're going to do that is to see, you know, if the key code is equal to any of those. But remember one other thing, right, is that our key code could be, let's do it here. Our key code, if it's pressed correctly, is going to be something like that, right? 1 exclamation point. So if I want to see if key code is equal to that code, what's that going to give me? Anybody know? Those two things are the same. Whoops. Oh, you know what? Sorry, I forgot to do this. Key code equals KB name key code. All right, so now key code is 1 exclamation point. If I want to test to see what that is, it's going to give me 2 ones, right? Because I'm comparing both characters to both characters here, right? So remember, I think I showed you guys there's a function called strcomp, or string compare, which is what we really want to use, which is tell us if 2 strings are identical, okay? And in this case, they are. That's 1 or true. So what we really want to do is say, if it's true that these 2 strings, one of which is key code, and one of which is one of the response keys that we want. So response keys J, again, curly braces because we're taking it out of a cell matrix. So if the key code is equivalent to one of the response key codes that we want, we can say good key pressed equals true. And we probably want to record the response, right? Now, one nice little trick we can use is the response keys. The possible syllables are ba, da, and ga. We said that ba is 1, da is 2, and ga is 3, right? So if we match the first response key, which is the key 1, we know that the syllable they're answering is ba, right? If they press the second response key, the syllable they're answering is da. And if they press the third, they're answering ga, right? So what we can say is, if we want to record what their response is, we can say this response equals syllables J, right? So that says that'll give this response as a string, basically saying that they pressed a key corresponding to the syllable ba, da, or ga, right? Okay, so that will set good key pressed equals to true. That'll get us out of the loop, and then we're good to go, right? So let's see if this code works, and then if it does, we'll take a little break, because I know that's a lot. Okay. So middle and the 1, 2, and 3 keys. Okay. Get ready for loud noises on the podcast.
Da.
All right, was that ba, da, or ga? I think it's da, which is the 2 key.
Da.
Yay.
Ga. Ga.
Is it just me, or does that look a little off center? Yeah, it looks like everything's a little far to the right.
It looks like everything. Did you reset?
Da.
Looks a little weird.
Ba. Da. Ga.
I'll have to fix that. I don't think that happens on the...
Da.
All right, well, anyway.
Ba.
Anyway, it basically works, right? I think, let's see, did we screw anything up? Yeah, I think we're all right. All right, I'm not sure why things are getting a little uncentered. I'll figure that out later. Or maybe it's... Well, anyway, we'll worry about that later. So just let's do one more thing before we're done. Let's just to prove that we can test now to see if people are accurate, and then we'll go back and record accuracy a little bit formally. At the end of each trial, let's say something like, let's display what the sound was, which is going to be, what was the sound this time? It was going to be sound num. So the actual sound played was syllables sound num, right? And the text shown was syllables text num, right? And the response was syllables, or no, we actually already said it was called this response, right? So if I want to, just as a rough, quick way of measuring behavior, I can just print that all out to the display. Yeah, because it automatically centers the text, so I'll have to figure out why we have weird uncentered stuff later. Maybe I did something weird.
Ba.
Okay, so there's ba,
Ba.
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 Let's get the third one, or let's get this one wrong. So remember trial number 3, I said ga instead.
Ba.
Let's say I got the next one wrong too. That said da there.
Ga.
All right, then I answered right.
Da.
Da,
Ba.
ba.
Ba. Da. Ba.
Okay, and we've got a little basic behavioral output, which we could have put into a file or something, but the sound was ba, the text was ga, I said ba. The sound was ba, the text was da, I said ba. The sound was ba, I said, or text was da, I said ga incorrectly. Ba, da, I said da incorrectly again. Ga, 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 and the rest was all right. Okay, great. So far, now this is going to get cooler as we go on because I have a whole, like, we have a whole ways to go with this to kind of get a full task out of this. But, you know, you can kind of see now we've got a pretty basic, you know, full-on Psychtoolbox task going where we're, you know, presenting sound, we're presenting text. In a little while, we will present images, hopefully, if we can, although you've already seen some images presented. We're measuring behavior with key presses, and all we haven't done yet is we haven't recorded like RTs and calculated accuracy and so forth, but we can do that with just a couple more lines of code, actually. So we've got 72 lines of code. Really, if we get up to about 10 lines or 15 lines more of code, we'll have a complete task where we record accuracies and everything else. So maybe we'll do that after a break. Okay, so we'll start up again. Actually, just for the sake of the podcast, I know I just started up the keynote again, but let me actually get out of that. We said this during the break, but just for the podcast, we realized that some of our Windows users were experiencing difficulties because apparently for Windows, for some reason, you have to call this, but for Mac and Linux, you don't. But it doesn't hurt to call it in Mac either. So if you just throw in an initialize psych sound before the first time you use any psych port audio functions, that should be enough to get sound working on Windows. For some reason, it doesn't automatically work if you don't initialize it first. But if you do initialize it first, you're all right to go. Okay, so maybe before we go back to the coding, because we're going to mostly code up till 4 o'clock, just to finish this up. So this demo will keep going to the end of today. We'll see what we get through today, and then we'll do a bit more of that next week as well, because the end result is kind of cool, I think. So let's talk just a little bit about what I mean by dynamic stimuli, because I think we'll get into that a little bit today, and then we'll finish it up next time. So the thing to keep in mind is that really stimuli like sounds and images and so forth are really just matrices of numbers, right? We kind of talked about that last time when we loaded in sounds, and we saw that they're really just, you know, sound waves are really just like a list of numbers representing like the amplitude or the height of the sound wave. So sounds are these one-dimensional vectors of amplitude values or samples, or a sound might be a 2D matrix if you had something like stereo sound. So, you know, if you have a left and right channel, you might have a line of numbers for each channel representing that sound wave in each channel. But in its simplest form, a sound is a one-dimensional vector of amplitude values. An image, of course, you know, when you look at it, it looks like a picture, but how it's really represented in the computer is as a two-dimensional matrix of brightness values, right? So, you know, what's really being stored in the computer is this 2D matrix, and, you know, each pixel has a brightness, and that brightness is represented by a number. So what looks to you like a grayscale image is really just a grid of numbers, right? And of course, if you have multiple color channels, like if you have a color image, then you've actually got a three-dimensional matrix because it's, you know, a two-dimensional image in red, a two-dimensional image in green, and a two-dimensional image in blue. So what you've really got is an X by Y by 3 matrix to represent a color image. But for a grayscale image, you know, it's a 2D an image is just a 2D matrix of brightness values. So the main point is that these are, in a computer, sounds and pictures and things like that are represented by grids of numbers. And of course, MATLAB's special talent is manipulating all kinds of matrices, all kinds of grids of numbers. So in MATLAB, it is relatively easy to do things like add, subtract, or otherwise do things to raw stimuli to make new, quote-unquote, dynamic stimuli, or stimuli that you create or modify, as the task is running, or even build them from scratch. So what we're going to transmogrify this demo into. First, we're going to kind of finish this demo, like to record response time and things like that. But then what we're going to transmogrify this demo into next, you've already seen that we don't really get what we call something like a McGurk effect, right? The text isn't really influencing our perception of the sounds, but maybe that's because it's too obvious what the sounds are. So we might ask a subsequent question, what if we presented text along with ambiguous sounds by blending together two sounds to make something in between two syllables? So that'll be our second demo. But first, let's finish up the first one. But basically, the point is, once you've got these basic stimuli that you read in from a file, you can use MATLAB to manipulate them, to degrade them, to mix and match them, to kind of do like a mashup of different stimuli. You can do all kinds of crazy things. And that's really one thing that MATLAB's really good for. You can do this stuff in CyctoPy too, but it involves like importing more external modules that kind of act like MATLAB anyway. So in a lot of ways, it's easier to just use MATLAB for this kind of thing. Okay, but before we do that, let's finish up our original McGurk demo before we go to McGurk demo 2. Let's see what we've got left to add in terms of features to this. So we're pretty good to go. So we can record data. Let's see, initialize it. Just seeing what else we do in my demo code that we haven't done yet. Well, the main thing we would want to do probably is save our behavioral data, right? So what we did last time, just as a quick fix, is display some output at the end of each trial telling what we just had and what people did. But what you might want to do instead, or in addition, is to save, all of this information about each trial into a matrix so that then you could like write it to a file or something at the end of the task, right? So let's do that at least. So let's add a little bit of code here. Before we start displaying our trials, let's create some variables to hold this information. So let's make one called sound list, and I'm going to make that an empty cell matrix. So that's two curly braces with nothing inside of them. And let's also make a text list, which is again an empty cell matrix. A response list, another empty cell matrix. And let's make a matrix, or really a vector of RTs. And let's just make that an empty numerical matrix with two square brackets, but not curly brackets. Okay? So ideally what we want to record is sound list, text list, response list, and RTs. And of course we could use these to calculate accuracies as well. But we won't bother calculating accuracies right now. It's pretty obvious how that would be calculated, I think. We don't need to add it in just at this moment. Because again, you might also consider accuracy as sort of one way to think about this task. But of course, what we really want to see is like if the text or whatever does influence your perception of the sound, how does it, right? So simple accuracy analysis might not be the most sensitive way to do that. You might want to see like when people don't judge that the sound is what the sound is, what kind of error do they make? So simple accuracy may not be as useful as something else for later analysis. So anyway, what we would normally do, I think, is spit all these out to a file. We won't show you how to do files in MATLAB just yet, but at least we can save them and show you how we would use them. Okay, so basically all we want to do, once we've created these empty things, the only thing we haven't done yet that we're going to need to calculate one of these, we actually know what our sound is, right? We know what syllables sound num, and we know what our text is, it's syllables text num, and we've already said our response is this response. The only other thing we need to do is calculate the RT and then like add to those lists at the end of each trial. Now, if we need to calculate RT, of course we need to know two things. We need to know when they pressed a key, which we do know here, right, because we record key time for each of our key presses. And we need to know what we're measuring that key press relative to, right? So what event occurs that we're measuring response time relative to. Because this key time, as you see, is just some large number, like the number of seconds since your computer was turned on. It's not useful without a relative time measure. So what we're probably going to use, I think, as our time measure, let me see where I did it here. So probably the right time to do it, probably the right time to define the beginning of the trial is, where is it? Here. So this is where we display, where the screen is flipped here, is where we display the syllable on screen, and then as soon as the syllable is displayed on screen, we start the audio, right? So what we want to really do is just, if you look at the screen flip subfunction, so Psychtoolbox screen flip, what you'll basically see, this gets really complicated. There's all these different timestamps that that Psychtoolbox can report, and I mean, it can get really, if you've got good hardware, it can get really specific. Like, it can give you a timestamp if you're using an old school like cathode ray tube instead of an LCD monitor. It can tell you kind of like a timestamp based on where the electron beam is and all this crazy stuff. But all we want is kind of a basic timestamp of when the item came on screen. So to do that, we can just take the first output. It's called VBL timestamp, but it basically means like when the screen flip started. So what we can just do is we can say something. We can call it something like stim onset time equals. So we can just take the first output variable of the screen flip subfunction, and then we know, according to the internal clock, what time the screen was flipped. And again, this is a bit different from PsychoPy, right? Because in PsychoPy, you have to create a clock object. And you know, when you create the clock object, that becomes time 0. In Psychtoolbox, the clock is always running, and you just decide when you record what the current time is, right? So if we record the time that the stimuli appear on the screen, and we record the time that the key is pressed, then all we have to do is subtract those, right, to find what the RT is. So what we can do is, I'm going to take this code out. We're not going to use it exactly, but I'll put it there for safekeeping for the moment till we might do something similar at the end. So what we're really going to want to do is at the end of each trial, you know, when we get past this while loop, we've got our key response, we're ready to go to the next trial. What we probably want to do is just say sound list. Remember, I think I showed you this trick before. If we say end plus 1, so sound list curly braces end would give us the last item, or would refer to the last item in sound list. If we say end plus 1, what that's basically saying is we're going to tack an item on to after the current end of the sound list. We're going to set the end plus 1 position to, you know, in other words, a position that doesn't exist yet. We're going to set the next item after the end of the list to be equal to, remember we said the sound played was syllables, curly brace, sound num, right? And similarly, if we want to tack the text that was shown onto the end of the text list, we can say text list n plus 1 equals syllables. And remember, like down here, we said that was syllables. Text num, again with curly braces because these are all cell matrices. The response list, add to the end of that what we called this response, because we've already calculated that was syllables j up here. And then the only other thing we need is RTs. RTs, now we use curly brackets or parentheses here because this is a regular numerical matrix. But we still can say n plus 1 equals, and basically we're going to want to subtract key time minus stim onset time, right? So that'll give us all our RTs. Now, if we want to be really user-friendly to ourselves, basically, what this is going to give is it's going to give this time in seconds. But what we may want to do is, express it in milliseconds and say like round to the nearest millisecond. We did that a lot in PsychoPy. So if we want to do that, we can put the whole thing in parentheses, asterisk 1000 to multiply it by 1000. So that'll put it in milliseconds. And then if we want to round it to the nearest millisecond, which seems reasonable because we don't need a bunch of decimals off the end of that, we can say, we can enclose all of that in the Matlab Round function, which will round that to the nearest whole number. So we'll now have a list of RTs in milliseconds. And then what we might want to do, just to prove that all this got recorded okay, like I said, what we'd really want to do is probably at the end of the task write a file out. But for now, let's just print it to the display. So instead, let's say, we could do this at the end. So after all the trials are presented, we can say for I equals 1 to n trials. Remember, n trials is how many trials we have. So what should happen is at the end of all the trials, we should have a list of, if we have 10 trials, we should have a list of 10 items in each of these that we can go through and print out all the behavioral data. So we can do something like this line. So let's take this line of code and then modify it. So we can display what the sound was, but instead of syllable sound num, the sound on this trial will be something from the sound list. And it'll be sound list item I, right, for the ith trial. The text will be the text list for the ith trial, right? The response will be the response list for the ith trial. And then let's also add in what the RT was on that trial. So our RT colon, and then now we're going to need to convert that to a string, right? Because it's a number, not a string. So we're going to have to say int to string RTs item I. And those are that's both round brackets. So I know that's a lot of brackets and parentheses and such, but that should do it right there. Okay. Now, by the way, you'll notice that I get a lot of Matlab warnings in my code. These are things that that are actually not totally optimal, but I am not bothering to tell you guys about fixing them for now. So we'll say for now that these are not computationally optimal ways to do these lines of code, but we're not going to worry about the details for you guys because it really doesn't matter for what we're doing. It would matter if we were doing something that had to be like repeated millions of times a second. That we'd want to be really efficient, but for us it doesn't really matter. Okay, so for our purposes, I think it's pretty flawless code. Let's see if I'm right and this works as expected. Okay, once again, if you're listening at home, watch out for the loud noise coming now.
Ba.
That was ba. Oh, shoot. Yep, I typed something wrong on line 77. I called it text. I meant to say text list. I don't know what I did there. Text list. Notice, though, that was a legit error, and thanks to our magic cleanup line, I didn't have a weird window stuck on my screen, so that was very helpful. Let's try it again. Okay, watch out for loud noises.
Ba. Ga. Ba. Ba. Da. Ba. Ba. Ga.
I'm going to wait a really long time just to prove that the RT works on this one.
Da. Ga.
Okay, so there we go. So now you see that Psychtoolbox gives you spits out a lot of info here, so that's a little annoying that we have to read around that. But overall, looks like it worked right. So prints out all the sounds we saw, the text we saw, what all my responses were. Was I right 100% of the time? Ba, ga, ba, da. Should have been ba, ba, ga, da, ga. Yep, I was right. See, there's one really long one here, but generally my RTs were around a second or so. So that's pretty good, I would say. Okay, so that looks like it works, right? So we've got a functional task in only 84 lines of code, which is not half bad. Now, whether this is useful as a real experiment, who knows? But, you know, with a little tweaking, it could be, actually, I suspect, if you really cared about how text affects people's response times to hear a syllable. But like I said, so we've got about 12 minutes left. Let's see if we can quickly modify this a little bit to kind of make things a little more ambiguous, to see if we can help ourselves, help our scientific hypothesis. Because, like we said, it's a little bit too easy right now. You could easily tell what the sounds are, but maybe if we did something like average together two of the syllables, we'd be able to create a more ambiguous stimulus that then might be affected by the text, okay? So I'm going to call this McGurk Demo 2. You notice Matlab gives you a warning that you should call the function the same thing the file's called, so we'll just change that there. So I don't have to change too many things here, actually. You'll see that I can pretty much use my existing code, but what I'm going to need to do is, on each trial, I'm going to need to pick two sounds and blend them together, okay? And then we'll see if, that blended sound is affected by the text we choose. So the way I've chosen to do this is, let's say I have like one main sound and one secondary sound. So, I could say like, all right, I want to make a combined sound that's 60% sound 1 and 40% sound 2. So maybe we'll, just to get this done before the end of the day, maybe I'll go kind of quickly through this, and then next time we'll do a little bit more explanation, but this will let you guys play around with this some. So one thing I'm going to do is define a variable called sound proportion, which is going to be like what relative percent each of the sounds is going to be. I'm going to set that to 0.55, which means basically 55% is first syllable, and then the remainder 45% second syllable, if we set that to 0.55, right? So that's what that'll be. And then one other little thing we're going to have to do, one slightly annoying thing, is that when we read in all of our sounds, they're actually going to be slightly different lengths, just because these sound files are not all exactly the same size. So one thing I'm going to do is I have to equalize all the sound lengths after I read them in. So what I'm going to do is add a few lines right here after I load in all the sound data. Well, one thing I'm going to do, I'm going to, inside here where I load in all the sound data, I'm going to create one more variable called sound lengths. Set that equal to an empty numerical MATLAB matrix with square brackets. And I just want to record how long each sound is so that I can then know which one's the longest one. And basically what I'm going to do is I'm going to add some empty, some silence to the beginning of the shorter sounds so that they all add up in the end. So they all end up to be the same length. Because I can't really blend two sounds together if they're not the same length, right? So what we'll do is I'll just say sound lengths n plus 1 equals length of each sound data. All right, so now I'll end up with not only all the sounds read into the sound cells variable, but I'll have a list of sound lengths, which I just spelled wrong, lengths. All right, so now what I can do is I can write a little chunk of code that equalizes, I guess I could use British English here, all sound lengths. And the way I'll do this is first I'll find the maximum sound length. And MATLAB has a convenient function called max, which gets the maximum item in a list of numbers. So the max of sound lengths is the longest length of any of those sound files. And then I can do another loop through the syllables for I equals 1 to n syllables, which is going to let us loop through all the syllables again. And what I can say is if sound lengths I, which means the length of the current sound, is not equal, right? Squiggly equal means not equal to the max sound length, because I don't have to change the longest sound. So I only want to do this for the non-longest sounds. What I can do is I can say sound length difference equals max sound length minus whatever the current sound length is, so sound length I. So what this is saying is this is how many samples or how many zeros I need to add into the beginning of the sound file to like pad it out to be the same length as the others. And what I can do is I can now change sound cells number I to be what it was before. So I'm going to join two matrices together, and one of these things is going to be what it was before, so sound cells I. But I'm going to tack onto the beginning some zeros to indicate silence. And I'm going to put on as many zeros as the difference between the longest sound and this sound. So Matlab has a convenient function that's called zeros. So if I want 5 zeros or a 1 by 5 matrix of zeros, I can just say zeros 1 by 5. If I wanted a 2 by 5 matrix of zeros, I could say zeros 2 by 5, etc. So here I want a row of zeros that's 1 by sound length difference. Okay, so that's good. That'll just add some zeros to the beginning of every sound that's not the longest sound. So you've done that. And let's see what else we have to do here. So now what we mainly have to do, so we can go through all of our other code. We can initialize the Psychtoolbox and everything as before. The instructions text basically is going to be the same. Select the choice that best matches what you heard. So I think that's still accurate, right? Okay, so what we have to do now, though, is something slightly different. So now what we're going to want is two sounds to blend together, two different sounds to blend together. So what I'm going to do is I'm going to, instead of having this sound num here, I'm going to delete that. I'm going to create a little list called sound nums, and that's going to be this function randperm with the number of syllables. Now if you guys remember randperm, it's a really useful thing. So randperm of 3 gives me a random list of the numbers from 1 to 3. So if I do randperm 10, it gives me a random list of the numbers 1 to 10, right? So if I have 3 syllables, randperm 3 will give me 213, 213, 123, 321, 123, etc., right? So basically, if I make a random list of the 3 syllable numbers, then I can take the first one, call that sound 1 num, and that can be the first sound num, and sound 2 num can be sound nums 2. So basically I'll just take 2 random numbers between 1 and 3, but different ones, right? Because I don't want to mix the sound with itself. I want to mix 2 different sounds. And then what I can do is before, the sound I played was just one of the sounds, right? Sound cells of a sound num. But what I can do now is play, so I can say this sound equals, and I can combine 2 sounds. So I can take sound data, sorry, curly braces, so the first sound 1, and multiply that by the sound proportion variable. So what that does is that takes 55% of the first sound and then add that to the second sound out of the sound data. Well, not the second one numerically, like number 2, whichever one we chose the number of. So take another sound, multiply it by 1 minus the sound proportion. So if sound proportion is 55%, this will take 45% of the second sound That'll give us a blended sound. We'll play that, which we call this sound, instead of a single sound. Again, I know I'm going super fast. I just want you guys to see this. Then we'll kind of step through it more next time. And that's pretty much it, except that we need to modify our behavioral data lists. So the only other thing we have to do, we previously had sound list, so let's just change this to sound 1 list and sound 2 list, right? Because we want to record both of the sounds that went into the sound that we played. And then we'll say sound 1 list, and we add on it at the end is going to be syllables sound 1 num. Sound 2 list is going to be syllables sound 2 num. And then we'll display in our behavioral data sound 1 and sound 2. So let's do that. Let's see, so just change that to sound 2, and that to sound 2. And let's see if now we've got a dynamically created stimulus where it presents a blend of 2 syllables, and see if that is influenced by the text that we show. So again, get ready for some loud noises. Whoops, and we've got a crash. So let's see if we can fix this in the next 1 minute or so. Sounded on something. It says cell contents reference, non-cell array object. Oh, you know what? Sorry. I called it something different in my demo code in here. So sound cells was the name of the cell matrix that has all the sound data in it. Sorry about that. I just used the wrong name. I sometimes come up with different names from my previously written version while I'm doing this live, and it confuses things. All right, so loud noises incoming.
Ga.
I'm not even sure what that was. I heard a ba, I think.
Da.
All right, do people primarily hear da?
Ga.
Ga.
Da. Ga. Da. Da. Ga.
I think that was a ga and a ba, but I'm not sure which one there was more of. I'm going to say ba.
Ga. Da.
All right, let's see how right I was. So if I'm supposed to answer what the primary sound was, that's the one that there's 55% of. There was a ga, but I said ba. Da and da, da and. Okay, so I answered sound 2 again. So it sounds like. So I got that one wrong. Da. I said ga there. So it seems like when it's da and ga comes out easier than the da. Ba and da, I responded da. Da and ba, I said da. Ba and ga, I said ba. Ga and da, I said ga. Da and ba, I said da. Okay, well, so sometimes I get it right, sometimes I get it wrong. I think what you can find here is that some of the syllables probably have a stronger influence on your perception. Even if you like blend them approximately equally, I think sometimes the second syllable is more easy to hear than the first one. But anyway, the main point is that's kind of cool, right? That we could adjust in real time, without having to make a bunch of new sound files. We can just adjust how much of these are together. So, right, if we wanted to go back and make, if we wanted to make it really hard to distinguish between the 2 sounds, we could just make the sound proportion like, well, let's say 52%, which means that now we want to do a task where it's 52% of one sound, 48% of the other sound. I mean, again, this may be harder or easier depending on the syllables.
Da.
That sounded like da.
Ga.
I don't know.
Ga.
It sounded like ga.
Da.
Da.
Ga.
Ga, I think.
Da.
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 Ga.
Ga.
Da.
Da.
Ga.
Ga. All right. So anyway, you could do something with that, I suppose. You could analyze the RTs and see if the text influenced things. And you could do lots of other stuff. Like we could do a kind of psychophysics thing. Instead of just picking a random proportion, we could maybe do a psychophysics task to see, what blending of two syllables is necessary to make it like perfectly ambiguous which syllable is which, and then see if the text influences that, or all kinds of crazy stuff like that, right? But it is cool that we can generate these stimuli on the fly. Okay, so that's it. We're a little bit over. Next time we will talk about, we'll keep doing a little bit of this because I have a picture version of this as well. We're going to go back to doing McGurk with pictures or like with videos, but we're going to make the videos kind of ourselves. And we'll explain this a bit more because I know that went super quick, but I wanted you guys to have this code more or less complete so that you could play with it if you wanted to over the coming week. Okay, any questions before we adjourn? All right, so adios for now.